Welcome back to Lesson 0, Trig Identities, Part 3 or tool number 3, Factor and Simplify. So the first one again is done for you. Let's go on to the Part B. Part B, now this left side, not much can be done with this. None of these are squared, so you can't change them into cos. Not that I'd want to, but we're kind of stuck here. But both of these are squared, and that's actually quite advantageous to us. How is that, Mr. Wills? If we look at this top here, and this is hard to see, but if we look at the top here, this guy here is actually a, bear with me, a difference of squares. Why? It's two terms separated by a negative, and they're both squared. One squared? Absolutely, 1 squared is 1. This guy here is also squared, so what do I do here? What can we do here? Well, we can difference is squared that. So I'm going to tackle the right side here. So I really have this right side, and here we go. So I'm going to change this sign squared x minus 1 to square root the first term. I get sine x for both. Square root the last term, I get 1 for both. So 1 here, and I'm going to add them, and I'm going to subtract them. Now on the bottom here, I'm going to write it out twice. Sine x plus 1. And hopefully you can see what I'm doing now. Sine x plus 1. What beautiful things happens here? Well, these sine x's are canceled because they're both being multiplied in the other one. And guess what I have? Now I've just got sine x minus 1 over sine x plus 1. Done. So because left side is equal to right side, therefore, quae resta demonstratum. All right, let's go to the next one. Here we go. Part C. So I definitely have to tackle the left-hand side, the right-hand side, sine x plus cos x. This is not an identity. This is not equal to 1. This guy here is not equal to 1. And again, why? Because these terms are not squared. So what do I need to do here? I'm going to have to tackle the left side. So I'm going to tackle this left side. Now, how am I ever going to do this? Because I got 1 plus 2 sine x cos x, and then here I've got sine x plus cos x. So this is, bear with me again, here we go. So what I'm going to have to do with this one is, I'm actually going to change this 1, and I'm going to change this to sine squared x plus cos squared x. So I'm kind of reversing what I usually do. I usually look to make that the sine x squared plus cos x squared 1. Here I'm going to actually change this. So what do I have? I've got here sine x squared plus cos x squared plus 2 sine x cos x all over sine x plus cos x. Mr. Wills, what will happen here? Well, if you bear with me, this guy here will actually, we can actually look at this. If sine x is equal to, let's say sine x is equal to a, cos x is equal to b, then I really have this. Got a squared plus b squared plus 2ab, which can be rearranged as this. A squared plus 2ab plus b squared. And guess what this is? This is what we call a perfect square. First and last term are perfect squares. And if I square root both of these and multiply them by 2, I get the middle term. So this is really equal to a plus b all squared. So guess what? I have that exact same thing here on the left side, except that it's in sine and cos. So sine x squared plus 2 sine x cos x plus cos squared x all over sine x cos x. So what's this really equal to? And again, this guy here is really equal to this. So what do I have here? I really have this. I have sine x plus cos x all squared all over sine x plus cos x. What can I do here? Boom, boom. What am I left with? I am left with just sine, whoops. Left with sine x plus cos x. So, done. Because the left side, oops, equals right side, Therefore, Q, E, D. Ooh, don't know where that line came from. So that's the end of part 3.